Hello, algebra students. Mr. Lawrence here, and we are going to do our next flipped lesson. And today you will be able to say, I can multiply and divide like bases. I can raise a base with a power to another power. Yes, we've already done these lessons, but got to make sure we're really good at them for what we're getting ready to do next. Okay, so we're going to take a day and make sure that we're really getting this material down. Hopefully, if you're not, you're coming in for help at lunch or possibly after school. All right. So I'm going to walk through these as if you don't know how to do them. If you at any time want to pause the video, try the problems ahead of time and see if you get the same answer, that's awesome. That means you understand what's going on. And then maybe you can just skip through my explanations. But if you're having trouble with any part of these, then watch my explanation because maybe the second or third or 50th time around, it'll sink in. Hey, and I don't mean that as a put down. I know sometimes I just don't get it till I've heard it like 50 times. It just doesn't make sense. And then all of a sudden it does. I can't explain why. So if you think, like with number one here, if you can go ahead and pause the video and get the right answer, and then you're confident it's right and you just want to skip to where I show the answer, don't sit and watch my whole explanation. It's a waste of your time. But if you're having trouble with number one, you're a fool if you don't sit and watch the whole explanation. Okay, well, let's get on to it. Number one, I am going to highlight this 5 and this 3 in one color, and I'm going to do the x to the 7th and an x to the 4th in another color. Those are the things I'm going to multiply together. And I'm going to do the 5 and the 3 multiplication, get 15, x to the 7th times x to the 4th. Now, some of you might be forgetting how to do that. Okay, well, how many x's do I have here? 7, 1, 2, 3, 4, 5, 6, 7, right? And they're all being multiplied. And here I have 4 more being multiplied. How many x's are being multiplied together? 11 of them. What's the easy way to say that? X to the 11th power, right? Now the shortcut is to go, hey, when I'm multiplying, I add the exponents. And that is true, and you can do that. But be careful. Make sure you understand why it works. This part is the y, okay? This is the y. It is easier to just go 7 plus 4 is 11. But if you don't understand it, it's going to cause you trouble when you get down to problems like 5 and 6, okay? Make sure you understand why. All right, on number 2 here. Let's see, let me get my highlighters back out. All right, and I'll do my coefficients in yellow. Looks like I have 3 coefficients. And I'm going to do my x terms with their exponents in green. All right, I think this will show up okay. Yeah, my y's in blue. And my z's in this magenta kind of color here. So I'm going to multiply the yellow ones together. I'm going to multiply the green ones together, the blue ones together, and the magenta ones together. Just multiplying my coefficients. And let me see here. I think I'm going to get 42 when I do that. By the way, like I wouldn't do 2 times 7 times 3 because I don't know 14 times 3, but I would do 3 times 7 is 21, times 2 is 42. Or maybe I would have done 2 times 3 is 6, and 6 times 7 is 42. Anyway you slice it, you're going to get 42. And since multiplication is commutative, you can change the order. All right, now my green ones. I've got 5 x's being multiplied here. 1 more x, I'm up to 6. 2 more x's, I'm up to 8. That'll be x to the 8th. Okay, if you need to see it, there's 5, there's 1, and there's 2 more. How many x's are being multiplied? 8, so it's x to the 8th. All right, my light blue ones, it looks like I'm going to have 11 y's. Okay, and then my z's will be to the 13th power, and there you go. Hopefully that this is real easy stuff for you by now. If not, come in and see me, please. All right, division's a little bit different, and I don't like division this way. I like division this way, right? And then I'm going to do the same thing I did in multiplication, only I'm going to be dividing. And I've got a 27 divided by a 9. And then I have an x cubed divided by an x squared. Well, 27 divided by 9 is 3. Now remember, x cubed over x squared means this. And what happens when you take a non-zero number and divide it by itself? Well, they cancel out, don't they? So these two x's turn into 1. These two x's can turn into 1. So right now, what I actually have in my problem is 1 times 1 times x over 1 times 1. This is the real long way of doing this. The numerator simplifies to x, the denominator simplifies to 1, and the whole fraction simplifies to plain old x. My answer for the x portion of the problem is just x. All right, that's the long way to do it. Need to be able to explain it, understand why, but you don't necessarily have to do it that way on every problem. On a test, I may ask you to do it that way. All right, one time anyway. Okay, so my coefficients, 60 and 12, x's, okay, there's my y's, and my z's, and then I'll go ahead and divide. So I'll do 12 divided by 60, and that ends up simplifying to 5. Now I have x to the 10th over x to the 5th. Can you see the 10 x's in the numerator? The 5 in the denominator? Won't 5 of them cancel with each other? So I'll be left with 5 x's being multiplied, which is x to the 5th. All right. Y to the 8th over y squared is going to be y to the 6th. And then the last one will be z to the 4th. Now some of you are going, Mr. Lawrence, I noticed that 6 minus 2 is 4. Absolutely true. That's the how. That's a shortcut, and it works great if you understand it. Make sure you understand the y first. Make sure you understand this part of it. There's my numerator, and here's my denominator. And then these guys all cancel, leaving me, oh, wait a minute, silly Mr. Lawrence. I made my denominator too large, didn't I? Sorry about that. Okay, so there's my denominator. And then these guys cancel, leaving me with z times z times z times z, which is z to the 4th power. And that's what I have right there. Okay, a power raised to a power. Now some of you are going to get this confused because you're not thinking about what it means. This 3 here, this 3, let me circle that 3. That 3 means there's 3 of the things inside the quantity. So this is really this problem in disguise, right? X to the 5th times x to the 5th times x to the 5th. Well, in each one of these, aren't there 5 x's being multiplied? So I have 5 x's, 5 more x's, and 5 more x's. How many x's are being multiplied? 15. So that the shortcut way of saying all those x's being multiplied is x to the 15th power. Now notice you could do 3 times 5, multiply the exponents. That works. That's awesome. That's the way I do it. But you have to make sure you understand why. Okay, so the 3 out here means there's 3x to the 5th being multiplied together. So again, x to the 15th. All right, over here, I'm going to have 2 to the 5th power. Well, that's 32. Because 2 times 2 times 2 times 2 times 2 is 32. I have x to the 10th to the 5th power. Here, let me do it this way. Hold on. Let me move that 32 for now. I'll use them in a second. So I have, ooh, that didn't work. Okay, I have 1, 2, 3, 4, running out of room. 5, 5 of these guys being multiplied together. All the 2's. Okay, so all those 2's multiplied together will get me 32. Now, if I do all those x's, right, I've got x squared. Oops, that's not yellow. Silly Mr. Lawrence. I'll put that on my z because I'll use him later. All right, my x squareds right there. All right. It looks like I'm going to have x to the 10th power. And some of you are thinking, Mr. Lawrence, I could have just done 2 times 5 and got the 10th. Absolutely. I totally agree with that. Totally agree with that. Okay, but make sure you understand why. So we do my y to the 7th. Looks like I'm going to have 5 of them. And so there I'd have 7, 7, 7, 7, and 7. Well, that's going to be 35, right? So I'm going to have a y to the 35th power. And then my z's, where are you, z's? Okay, I also have to have 5 of those. Multiply them together. 5 times 9 is 45. So I'm going to get z to the 45th power. Okay, the video is almost over here. I have 3 problems I'd like you to do. I'm not going to go through long explanations. I'm just going to show my solutions. Go ahead and pause the video, get your answers, and then when you're ready, unpause. Okay, if you're ready to see my solutions, here they come. The first one will be 72 x to the 6th, y to the 16th, z to the 7th. Okay, the next one, number 7, will be 9 x to the 11th, y to the 7th, z to the 2nd. And the last one is going to be 25 x to the 8th, y to the 6th, z to the 10th. And there you go. There's my 3 answers. If you did not get those, if you don't know how I got them, please come and ask me. All right, even in class, to start class, Mr. Lawrence, I don't know how you got the answer to number 8, and I'll talk about it. Okay, Mr. Lawrence signing off. Good night, everybody.